Hey everybody, Sakani here. Today we're going to be taking a look at this problem, which is the volume of a spherical balloon is being inflated and changes at a constant rate. Initially, its radius is 3 units, and then after 3 seconds, the radius is 6 units. Find the radius of the balloon after t seconds. So one thing I want to point out is the one that I underlined, which says constant rate. In other words, constant rate just means linear rate. And in the context of this problem, for the first t equals 0 second, if it's increasing by 64 volume units, then in the second, it will also be increasing by 64 volume units. So that makes the problem a lot easier. And then we have initially its radius is 3, and after 3 seconds it's 6. So first, I know that the volume of a sphere is v equals 4/3 pi r cubed. And let's find the volume of the sphere at t equals 0, because when it says initially, we know that is t equals 0, and the volume when t is equal to 3. So I'm going to say v of 0 is equal to 4/3, and the radius when t is equal to 0 is 3 cubed, and that is equal to 36 pi. And then I'm going to do v of 3, which is equal to 4/3 pi, and then radius is 6 to the power of 3, which is 288 pi. Just to remind you guys that this is the time that we're looking at, and this is of course the radius, and they gave both of them in the problem. We just found the volume. Now I know that the volume increases at a constant rate. So in other words, I can just use y2 minus y1 over x2 minus x1 to find that constant rate. So I'm going to say 288 pi minus 36 pi over 3 minus 0. And that is equal to 84 pi. So every second, the volume is increasing by 84 pi volume units. Now I'm going to write the volume equation, and I know that it's just mx plus b because once again it's linear. Volume I know of a sphere is 4/3 pi r cubed. This is going to be that slope we found, which is 84 pi. And this x is actually going to be t, because remember when we replaced our value in here, we said that was time. It's not radius, it's time. So we're going to say t plus b, and b is the initial volume at time is equal to 0, and we found that as 36 pi. And now it says find the radius of the balloon after t seconds. This entire equation is in terms of r and t. So I'm just going to find r in terms of t. And this is going to be our final answer.